Hi, this is Marwa, and today we will be discussing systems of inequalities. We have already discussed before systems of equations and linear equations, and that will help us a lot with this video. Now we will have 3 examples today. The first one, we will be graphing a system of inequalities to find the solution. And the second example, we will be actually writing a system from a graph. And our last example will be a word problem where we will be able to see how the systems of inequality are going to help us to solve real life situations. So let's look at our first example here. It says, what is the graph of the system of inequalities? And we have 2 inequalities, y greater than or equal to negative x plus 5 and negative 3x plus y is less than or equal to negative 4. Now, how do you graph an inequality? You start by graphing this inequality as if it's a line. So I have the inequality y greater than or equal negative x plus 5. I will pretend that it's a line and graph the line. Then I'll see what are the values that fulfill or satisfy the inequality when y is greater than or equal negative x plus 5. So how do I graph the line? Now when we graph the line, we will keep in mind the form of y equals mx plus b that we discussed before. Now m, which is the slope in this case, is negative 1, and we always write it over 1 because we have a rise over the run, and b is equal to 5. So when I'm going to start on the y-intercept, with the y-intercept on the y-axis, which is the point 5. This is my first point. Then I'm going to use the slope to find another point. So I'm going to go down 1 because the rise is negative 1, and to the right 1 because the run is 1. Now I have the 2 points and I need to connect them. Now before you connect 2 points on the graph of an inequality, you need to check if you have an equal sign or not. If I have an equal sign, when I draw the line, I'm going to draw a continuous line. So now that I need to draw a line, the line I'm going to draw is going to be a continuous line, and we will see cases where the line is dashed. Now, what I have graphed so far is the line y equal negative x plus 5, but it's not greater than or equal. How do I find greater than or equal? Now, the solutions of inequalities are not only in the line, but actually all the region that is above the line. Why am I saying above? Because I have greater than or equal. So I am assuming that all the values above this line are parts of my solution. Now, let's make sure by checking. Now, above the line, I have a point here, which is 5 and 5, right? So I'm going to check if this point is a solution. Point 5 and 5. How do I check? Now, is 5 greater than or equal to negative 5 plus 5? I'm substituting. I'm not sure yet, so this is why you put the question mark. Well, 5 is greater than 0. Then yes, then this part here is also a solution. So what do we do with it? Actually, we shade it. Like I'm going to say that all this part here, which is above the line, as far as my graph extends, is a solution. All of this. Okay? So I can actually try my best to shade, but that's going to take time. So all this part here is a solution. Not only the line, but also all the part above the line. Okay? Now, what I have graphed so far is one inequality. Let's graph the second inequality. Now, for the second inequality, we have negative 3x plus y is less than or equal to negative 4. There is 2 ways to do this. Either I graph by finding the x-intercept and the y-intercept, or we graph by changing this into slope-intercept form. If I changed into slope-intercept form, it means I want to isolate y, which should be easier. So to isolate y, I'm going to add 3x to both sides. Then you have y less than or equal to 3x minus 4. My slope is 3 over 1, and the y-intercept is negative 4. So at negative 4 on the y-axis, this is my first point. I'm going to use the slope to find the second point. I'm going to go up 3 units, to the right 1 unit. Then I'm going to graph a line. Again, if I have an equal sign, it means the line is continuous. So let's try our best to get an accurate line as much as we can. Okay, So this line is also continuous because I have an equal sign. If I didn't have an equal sign, this line would be dashed. Now, which part do I shade? Y is less than or equal, so I'm going to shade this part under the line. Why do I assume that it's under the line? Because the values of y here are less than the values of y above the line. However, if you don't find that convenient, you still choose a point to check. I'm going to choose this point here. So I'm going to check before I shade using the point which is 5 and -5. Now, some people prefer using 0 and 0 all the time, and even if it doesn't check to be correct, then they shade the other side, which is also correct. So if I check, I'm going to have -3 multiplied by 5 plus -5, and I'm still not sure if it's less than or equal to -4. -3 times 5 is -15, plus -5, that's -20, and -20 is actually less than -4. Then yes, I'm going to shade this region. So I'm going to shade this region with the same color, which is green. Now, if you see here, there is an intersection that happened between the two shaded regions. Like the shaded region of the green inequality and the shaded region of the yellow inequality intersected in this region here. The intersection region is the solution of the system. The intersection is the solution of the system. Any point in this intersection is a solution in the system. Let's make sure. So the solution of this system is any point in this region. It's not a point in this region, in this green only, or in this yellow only region. No, it is a point in the intersection between the two shaded regions. So let's pick a point here, like I'll choose this point, and this point is 4 and 4, and check if it's actually a solution for the system or not. So solution for the system, as we agreed, is shaded in both colors. I'm going to pick the point 4 and 4 and check if what I said is true. Now let's see how. For this to be a solution for the system, it has to satisfy both equations. So is 4 greater than or equal to -4 plus 5? Well, I'm not sure yet. 4 is greater than or equal to 1. So yes. Again, let's check in the other equation. Inequality. Is -3 times 4 plus 4 less than or equal to -4? Well, -3 times 4 is -12 plus 4, that's a -8, and -8 is less than -4, then yes. So the point 4 and 4 is a solution because it is in the shaded region with both colors, the intersection between both shaded regions. Any point in this area is a solution for the system. And this was graphing a system of inequalities. It showed you how to graph an inequality, one inequality, and how to graph another one and find the intersection to find the solution.